All right. So we did go through a couple of formulas yesterday for moles calculations. Let me just give a quick recap of all those here. Moles is equal to mass over mr. Moles is equal to number of particles over Avogadro's constant. And yeah, also now we're going to study another formula, the third one here, that is concentration, moles, and volume. This formula relates concentration to volume and to moles. You must have studied this before as well in your AS level syllabus. Concentration is equal to moles over volume. So the units for concentration are moles per decimeter cube, moles over dm cube. Dm cube is the unit for volume, and moles we already know the units for moles is moles. All right. So this formula here, the third one, you can use this for multiple calculations. You can use it to calculate concentration, moles and volume. You can use it to calculate volume with the help of moles and concentrations, and similarly moles with the help of concentration and volume. Let's do an example here. Let's say if you have 10 moles of sodium and you have, let's say, 100 dm cube volume of sodium. Okay, so now you're given with two physical quantities, the moles and the volume, and you're asked to find the concentration. So can you use this formula to figure out concentration, Dua?
Yes.
Yes, you'll just have to
Yes.
input the two quantities, right? And you won't even have to convert any units. All of the units are in the appropriate forms. So concentration is equal to moles, 10, volume is 100, 10, tens are 100. So concentration is equal to 1 by 10, right, in decimal form, 0.1 moles per decimeter cube, right? This is how you use this formula. Now, assuming that you already knew the concentration and you already knew the moles as well, and you had to figure out the volume. So in that case, you can again use this formula. Concentration was known, okay, 0.1. Moles were 10. Volume was unknown. Simple calculation, 0.1 times x is equal to 10. 0.1 on divided on both sides. X is equal to 10 over 0.1. 10 over 0.1 is 100. You can even use a calculator for that. And because we are finding volume, so the unit will be dm cube. And similarly, we can perform the same calculation for the moles as well. Let's say if you already knew the volume and the concentration now. So the concentration was 0.1, moles were x, and volume was, for example, 100. So if you multiply 100 with 0.1, you will get 10. So value of x is 10. 10 is the volume that's already stated here. So sorry, 10 is the moles. 10 moles is the answer. So see, we've calculated the three quantities with the help of the other two quantities by using this one formula. I hope this is clear now.
I don't understand the one where the volume is not given.
The one with volume is not given. Okay, so look at this. This is concentration, right? We're assuming that we already know the concentration. We calculated the concentration in the first step, right? So now what we're doing is we're assuming that concentration is given is 0.1. We're also you're talking about this one or this third one?
No, the one where the volume
Isn't given, the red one here. Okay, sorry.
Yes.
So in this case, again, we know the concentration, right? Concentration is 0.1. We know the moles. Moles are 10. See, this is given here, and we're picking up the concentration from this part. So assuming that this is the question here, forget everything else, that you know the concentration and you also know the moles and you're asked to find the volume. So whenever you're dealing with these three quantities, you should know that you will be using this third formula. Okay. And the third formula states that concentration is equal to moles over volume. Clear up till now?
Yes.
Concentration is 0.1. Well, we're going to write 0.1 here. Moles are 10. So we're going to write 10 here. And volume is unknown. So we're going to write x here. 0.1x is equal to 10. Simple algebraic calculation, right? 0.1 divided by both.
We will move the x towards the concentration.
Absolutely. We're going to cross multiply x with concentration.
Okay.
And once this x is cross multiplied, we're going to divide this concentration on both sides. A simple maths rule, right?
Okay.
So 10 divided by 0.1 is 100. X is equal to 100 dm cube. All right. Now,
Yes.
let's move on to the other formulas. Okay. So the fourth one here is it the fourth formula? Third one. Sorry, let me see. 1, 2, 3. Yeah, fourth formula. Okay. So the fourth one here is that volume of gas. Now we're talking about the volumes specifically for the gases. Volume of gas is equal to moles into 24 dm cube. Why? Because 1 mole of gas occupies 24 dm cube volume. This is a statement, okay? 1 mole of gas will always occupy, you can write it down, occupy 24 dm cube volume. This is a fact. And you might see a lot of questions based on this fact as well. A lot of MCQs in your exam paper. You will be asked to state the volume of 1 mole of gas. Any gas that exists in 1 mole quantity will always have a volume of 24 dm cube. Now, using this fact, we have established a formula here that volume of gas is equal to moles times 24 dm cube. Okay. So for example, now, if let's say you are aware of, example question could be that chlorine's moles are, for example, 0.5. Okay. And you're asked to find chlorine's volume. So what you're going to do is you'll use this formula. Volume is equal to moles into 24 dm cube. But the important, I think, yeah, okay, let's continue. So volume is equal to moles. Moles are 0.5. 24 times 0.5 is 12. So volume is 12 dm cube. I hope this is clear. All right.
Can you repeat this?
Okay.
Like,
so we simply knew the moles of chlorine as 0.5, right? And we knew and we didn't know anything else. We were asked to find the volume. So we knew that the formula states that volume is moles times 24. Moles were 0.5. We use these moles here times 24.
And then we just multiplied it by
Exactly.
24, which is the fixed value.
Yes, absolutely. And this formula is only valid for gases at room temperature pressure. RTP is room temperature pressure, and that value is 25 degrees Celsius. So whenever, let's say, a question asks you to find volume of a gas, and you are using this constant 24, you will only be using this if all of the conditions are standard room temperature pressure. And room temperature is 25 degrees Celsius. Okay. Now, okay, we're done with all these formulas, and now we'll be using these formulas in the balanced chemical equations. This is exactly how we proceeded to the questions yesterday as well. We studied the 3 formulas, we moved on to the balanced chemical equations. Again, we now have at least 4 formulas, 4 to 5 in front of us. We'll be using these formulas in the balanced chemical equations to figure out unknown values. So for example, I'm going to write, okay, I'll write an example equation here as well. So use of balanced chemical equations. For example, that our chemical equation is Fe2O3 plus 3CO producing 2Fe plus 3CO2. Okay. So Now this is the equation here. Remember the first step that I told you yesterday was to first of all identify the substances, then the coefficients, and then you were to apply the ratios, right?
Mm.
So stoichiometry over here is that you identify all these coefficients properly. Let's say if I tell you to find the mass of Fe, mass here is question mark. And let's say if I tell you that the moles of Fe2O3 are 5. So we're identifying the two substances here. Number one, Fe2O3, okay? And the second
Mm.
substance is Fe. Let's write these down. Fe2O3 plus Fe. Sorry, ratio Fe. Fe2O3 has a coefficient 1 here. So we're gonna write 1. Whereas iron Fe has a coefficient 2. Now moles. 5 moles for Fe2O3 and X moles for Fe. So X times 1 is X. 5 times 2 is 10. So X is equal to 10. So now we know the moles of Fe as well, 10 moles. But the question here was demanding mass, not moles. So what should we do now to find out mass here?
Use the first formula.
Absolutely. We're going to use the first formula. Moles is equal to mass over mr. Moles is equal to 10. Mass is question marks. We're going to write X. And mr, we can find the mr from the periodic table, right? Iron is 56. You can even check. So 56, can you maybe confirm? I think it is 56.
It's 55.6.
Okay, perfect. So we're going to use 56. Okay. 56 times 10 is 560. So 560 grams is the answer. Simply cross multiplication. We're done. Okay. So what was the difference in this question here? The questions that you were attempting yesterday were just asking you to find direct values. For example, the moles here. But today in this question, you used that value to calculate another value by using an equation here. Okay. So this is also another way to attempt questions regarding these balanced chemical equations. You can first figure out an unknown value with the help of an equation, and then you can use that unknown value along with an equation to figure out a derived value. I hope you're getting this.
Yes.
I'm writing this in the bracket here, derived values. Derived values are all those values that you figure out by using equations, okay? An example of this is the question that we just did. Moles is equal to mass over mr. This is the equation that we used. And the supporting quantity was the moles that we figured out because of from the Stoichiometry method. And then we use these moles alongside this equation to figure out the mass. This is the derived quantity here. Mass is the derived quantity. So you should understand the difference here, that I mean you can use these balanced chemical equations for multiple purposes. Now let's use the same equation again for another quantity. So we have this carbon dioxide as well. What if I tell you the moles of iron Fe2O3 are again 5? Okay, we're going to use the same moles. You're asked to find volume of carbon dioxide now. Therefore, you can use an equation for multiple quantities at once. So now we're establishing the ratios between Fe2O3 and CO2, right? So let's write these down. Fe2O3 ratio CO2. Now look at the coefficients. Fe2O3 is again 1, yeah? And carbon dioxide is 3. Clear up till now?
Yes.
Okay. Because you're asked to find volume, volume is a derived quantity, because I mean obviously you cannot establish ratio directly between the volumes. So what you're going to do is we'll find out the moles. We know the moles of Fe2O3 that are 5, and moles of carbon dioxide are X. Okay, again cross multiplication. X times 1 is X, 5 times 3 is 15. So X is equal to 15. This ye kya hai? These are the moles of carbon dioxide. But Again, the question doesn't need the moles, but the question wants you to find the volume. So what should we do now?
I use the third formula.
Absolutely. We're going to use the third formula. Um, that is, no, third or fourth?
The concentration one?
I mean, we don't know the concentration, so how can we use that formula?
Oh, then the fourth formula.
The fourth one, yeah. So volume is equal to moles times 24 dm cube. We know the moles, so volume is equal to 15 times 24 because 15 was the mole, so we've used this value here. What is 15 times 24? Could you use the calculator?
360.
360 dm cube is the volume of carbon dioxide. I hope you're clear now. Yeah, see how we've used multiple quantities and through just one equation. And you just knew one physical quantity, that was the moles. Moles of Fe2O3. By using just one data available, we figured out the mass, we figured out the moles of Fe, we figured out the moles of carbon dioxide, the volume of carbon dioxide. I mean, see how you can use just one equation to figure out so many unknown things. This is why we say that in chemistry, balanced chemical equations can give you a lot of valuable information. And this is very important. All right. Now, we're going to do another example, another similar example of using balanced chemical equations, because this part is the most important part here, because I mean, this topic moles and the use of balanced chemical equations is establishing a basis, a strong basis for the A levels chemistry exams, both the S level and A2 level. Okay, because once you get a strong grip of moles in the S level, you'll be able to attempt the questions of your second year A2 chemistry as well. Because this is the only time you'll be studying moles in both of these years, right? So just be very vigilant and just try to grab every concept. If you get stuck at any point, if you feel confused, just stop me right there, okay? Because it's important for us to understand the concepts here. All right. Now I'm gonna write another question, and you will be solving this. I mean, you'll be dictating most of the parts to me here. 2Na 3PO4 plus 3H2SO4 producing 3Na2SO4 plus 3H2O. And for this equation here, the data given to you is the moles of Na3PO4, 0.012 moles. You know okay, you're asked to find the moles of H2SO4, okay? You're asked to find the mass of H2SO4. You're asked to find the number of particles of H2SO4. So you see, you're just given with one quantity and they're asking so much information from you. And then you're also asked to find moles of Na2SO4. And you're then asked to find mass of Na2SO4. काफी है, आगे वॉल्यूम भी पूछूं H2O का.
वो भी ठीक है.
चलो, volume as well. Now we are asked to find 6 unknown quantities, and we're just given with one thing, that is moles. You don't get overwhelmed by looking at the question. It's pretty easy. We've already done everything before. You just have to establish ratios. So let's take it step by step. Okay. First of all, let's settle the quantities. Let's deal with Na3PO4 and H2SO4. Fine. For this, what should I do now?
It's between Na3 and H2SO4. Okay, first we're gonna write Na3PO4 ratio H2SO4.
Okay.
Then we're gonna put the coefficients, which is for first one is 2 and for H2SO4 it's 3.
Perfect.
For Na3, the mole is already given, but for H2SO4 it's gonna be X.
To 2x is equal to, 0.012 times 3, which is 0.036. And now simple division, 0.018. Yeah.
Yes.
Yeah. So now what do we know? We know the moles of H2SO4. Let's write it here. Is a 0.018 is moles of H2SO4, and we can cut this quantity from the question. We're done with this. Now, what's the second thing?
Mass.
Mass, this one here. So how to find the mass now? You know the moles of H2SO4, and you're asked to find the mass of H2SO4.
We're going to use the first formula.
Yes, we're going to use the first formula. Moles is equal to mass over mR. Moles is equal to 0.018. Mass is unknown. We're going to write X. MR is, you can use the periodic table to find the MR. Yes, MR milega. H2 is 1 times 2 because H2 mass is 1. 2 coefficient, you're going to multiply 2. S sulfur is 24 or 32, I guess. 32. Oxygen is OH2SO4, and oxygen is 16 times 4. Could you use a calculator and add all of these? You multiply, then add 32, multiply this, and then add 16 times 4. Could you maybe again check for sulfur? Is it 32?
Yes, it's 32.
Perfect. So simply write this on the calculator and get the answer.
$98.
98. So 98 is the MR of H2SO4. We're going to write it here. Now multiply 98 with 0.018 times 98 is
1.76.
1.76. So 1.76 is the mass of H2SO4. Let's write it. Mass of H2SO4. So we're done with another quantity. Let's cross it out. Okay. Now you're asked to find the number of particles of H2SO4.
We're going to use the second formula.
Moles is equal to number of particles over Avogadro's constant. You already know the moles. 0.018. You can write X for number of particles. Avogadro's constant was 6.02 times 10 raised to the power of 23. Cross multiplication, use a calculator. 6.02 times 10 raised to the power of 23 multiplied by 0.018. You're going to get the answer.
It's 1.083 into 10 power 22.
1.083 to 10 raised to the power 22. So these are the particles. Okay, particles will always be in a very large number, in a very large quantity. Okay, this is a hint. Okay? Your answer must be correct because you see it's raised to the power of 22. So number of particles. So we're going to cross this quantity out from the question as well. Now the next step is that you're going to establish a ratio between the first one and the third quantity, Na2SO4. And you're going to find the moles and mass of Na2SO4 by using the same method. And once you're done with that, you will be establishing a ratio between the first and the last quantity here. I hope you're clear with this.
Yes.
Can you maybe solve the rest of the question? The other two parts.
Yes.
Okay, perfect.
The
Mhm.
Na2SO4, it will be between Na3PO4.
Na3PO4 and Na2SO4. By the way, you can establish the ratio between even H2SO4 and Na2SO4. That's completely up to you because you already because you now know the moles of H2SO4 as well. Yeah, 0.018.
Okay.
So you can do that as well. But I'd suggest go with the first quantity. I mean, first quantity with all of the other quantities, so it will be easier for you to understand in a
Hmm.
sequence. Yeah?